This demonstration shows the effects of different atmospheric additions to the greenhouse effect. The setup is that each of these three has a shallow dish of water to simulate an ocean. It has a light above it to simulate the sun, and it has a thermometer in it so that we can check the temperature periodically. The first one, the one on the left, has no additions to it. It is just typically room air. The second one has CO2 addition. Notice it's clear because CO2 is transparent to our eyes at least. And the third one has CO2 plus smoke from an incense stick. The temperature will be taken every 5 minutes. This is what the microcosms look like after 60 minutes. Notice that all three have condensation on the glass itself. This is because as they heat up, the water in it evaporates and it condenses on the surface of the glass as it cools. The water itself is a greenhouse gas and makes the temperature rise. There is more condensation on the one with carbon dioxide because, as you will see in a minute or so, that particular microcosm heated up quite a bit more, so more water evaporated, but the difference between the outside temperature and the temperature inside the beaker was quite a bit higher, so there is more condensation. There is condensation that you can see in the third one, but most of what you see in there is still the smoke floating around. So let's take a look at the course of temperatures over time in each of these three microcosms. The control treatment, the one with ambient air, is shown in blue markers and blue dotted line. You can see that it went from room temperature, which was about 24 degrees Celsius, up to about 28 degrees Celsius, more or less linearly, but kind of tailing off a little bit. If you look at the carbon dioxide, that's the one with the red square markers and red line. Notice that that rose quite a bit more rapidly, up to about 29.5 degrees Celsius, about 1.5 degrees higher than the one with ambient air. The third one was carbon dioxide plus smoke. That's in the green triangles with the dashed line. That actually rose more slowly than the control. It's expected that the one with carbon dioxide would rise a little bit faster and would attain a higher temperature because it had added carbon dioxide and a stronger greenhouse effect. But what about the one with carbon dioxide and smoke? Well, the smoke is an aerosol. Instead of being a gas that could be dissolved and mixed in the air, an aerosol is something that is suspended in the air. And there are two different types of aerosols. There are light aerosols and there are dark aerosols. Light aerosols tend to act like little mirrors and reflect light away. It actually adds to the albedo of the Earth if you have a light-colored aerosol. Examples of light-colored aerosols would be things like volcanic ash and sulfur dioxide mixed with water, which makes sulfuric acid droplets, which are very reflective. Both of these occur after a major volcano. The volcano injects volcanic ash and sulfur dioxide into the lower stratosphere. where it combines with the small amount of water that is in the stratosphere to form sulfuric acid. And after a major eruption, world temperatures can decrease by about a half a degree, maybe even a degree, and stay that way, more or less, for 3 to 5 years. You can see the effect of the water vapor. That is what is actually causing the control sample to increase in temperature. And it's a combination of the CO2 and the water vapor that causes the CO2 treatment to rise much more rapidly. The CO2 starts the additional greenhouse effect, and as soon as the water starts evaporating more rapidly, the water vapor takes over and keeps the rise going. In the case of CO2 and smoke, this smoke acts as a light-colored aerosol and reflects some of the light away, so it keeps the CO2 from working as effectively. If it were a dark aerosol, for instance coal ash or something like that, or coal dust, then it would be a dark aerosol, and it would actually increase the warming to begin with, and then water vapor would take over and raise it even more.